Okay, good morning, everyone. We're about to get started with our second day of the 11th Annual Conference on Digital Experimentation. Did you hear me say 11th Annual? Some people may not realize exactly how long this conference has been going on. And anyway, it's really exciting to be opening our second day here. So first, I want to go ahead and really thank our sponsors for enabling us to put on this event in this great space with all this great support. So this year, that's Netflix is our premier sponsor. Amazon, Booking.com, and StatSig are all event sponsors. And I hope you enjoyed the reception last night. EPO is our reception sponsor. So as a reminder, there's this, if you haven't checked it out already, there's this sponsor room over there that is a good chance to chat with people from those companies, pick up cool stickers or socks or handbags, and find out if you want to work there. A couple little notes before we jump into today's plenary session. If you are the presenter of poster number 24 or 34, we don't have your slides for the poster slam today. So what's going to be happening today, right, is that all the posters were on display during the reception yesterday. All those posters are going to be on display during the reception today as well. But during lunch today, we're going to do the poster slam for the other half of the posters. So 24 and 34, please check in with the AV team. Similarly, actually, for session, this is a little bit later in the day, but for session Q, the presenters 2 and 5 in there, we are also missing your slides. So it'd be really helpful to get those in. Okay, so we've got another great day ahead of us. We're going to start with a plenary session. For the plenary sessions, we have 2 speakers, each who are going to speak for just about 25 minutes. We'll take 1 question or so in between them, and then we'll have the rest of the time for a broader conversation with both of them and taking your questions. And then we're going to go into a coffee break. If you're a presenter in the next parallel session, that is the time to make sure you check in with AV and with the chair for that session so that everything is ready to go when we're going to start at 10:25, the parallel sessions. Today, we actually have 4 tracks of parallel sessions. So yesterday, we didn't manage to get our hands on all of the rooms on the 6th floor. And today, we have 3 different spaces on the 6th floor as well as this space. So it's actually going to be 4 tracks for the parallel sessions today. So more hard choices for you. Okay, so I don't want to delay us further because we have limited time and a bunch of really interesting work to hear about. So in this plenary session, we're going to start off with Avi Collis from CMU. Take it away.
Thanks, Dean. So I'm very happy to be back at MIT. I remember my first code when I was a grad student here, 2015 or 16, like when it was way smaller than this. So very excited to see how the conference has grown in the last decade. So today I'm going to present some new work we did with Meta. The research is about measuring the disutility from ads on Facebook. This is joint work with Eric Brynjolfsson and several co-authors from Meta, Asad Liaquat, Daniel Dijsselroodt, Daley Kutzman, Harriet Sgarrow, and Niels Wernerfeldt, who is now at Northwestern. So the motivation for this research is, to answer this question of do they cause utility or disutility, right? So on one hand, one could argue that ads can play an informational role, matching buyers and sellers, reducing search costs, thereby creating some utility. On the other hand, we have research, including from people in the room like Dan Goldstein and co-authors, showing that ads could be annoying. They can impose a cognitive cost. And also, there is some new work by my colleague Alessandro Acquisti showing that potentially because of behavioral targeting, users may get exposed to lower quality or higher priced products. So, one could argue that, ads could cause, utility or disutility, and this is what we're trying to measure, what is happening in the field on Facebook, what is the net effect of ads on consumers. So when we were looking at the literature, there isn't a lot of work. There is some work, but there isn't a lot of work on measuring the consumer welfare implications of online ads. I think it's for a couple of reasons. So first is, it's like hard to run field experiments, right? In an ideal experiment, you would run experiments like switching on and off ads. It's challenging to run, as many of you would probably know. And in general, measuring consumer welfare or consumer surplus, it's quite challenging, for free digital goods when there are no prices and quantities. Demand curves are not, they're not like readily available. So because of these challenges, we haven't seen a lot of work like putting a dollar amount on the consumer surplus of, seeing ads. So what would the ideal experiment look like if you want to measure, how much utility people get from ads or not? So the ideal experiment would, randomly switch ads on and off in the field and over a long period of time. It should be a field experiment because, if it's an online experiment or a lab experiment, there could be concerns with hypothetical bias if the choices are not incentive compatible. There could also be issues of experimenter demand effects. Like, if you ask someone in an online experiment, do you like ads? Like, I don't think many people would say yes. So we need to be looking at like reveal preferences in the field. It also should be a long-term experiment because it can take a while for users to adjust their behavior if you do any experimentation changing ad loads. And there is a great paper from Pandora showing that, in that experiment, they change ad loads over the course, and the treatment, happens over the course of almost 2 years. And what they find is, if they had stopped the experiment, after a few weeks or a month, they would have been quite off, from the true estimate, and which they had, because they kept the experiment running for over 2 years. So we would want a field experiment, and we would want a long-running experiment. And while working with Meta on a different project, we basically stumbled upon this ideal experiment, which was already happening internally at Meta for other purposes. So basically what we're doing is, exploiting the holdout group of, Facebook's A/B testing platform. I don't have to give you much context about, what a holdout group is, but, just for some background, right? Like as all of you know in this room, all these big tech companies like Facebook, Google, Amazon, run, the entire conference code is around this topic, right? Like run like hundreds or thousands of A/B tests every day. Many of these A/B testing platforms, right, like have a clean control group or a holdout group, and the objective is to measure the cumulative impact of, all the interventions which are being tested over the long term. And for Facebook, this holdout group is basically a group where the users don't see any ads. And that's the holdout group they have been maintaining. So this is what we look at. So, so Facebook launched, this particular holdout group experiment in 2013, and it's been continuously running since then. So, since 2013, 0.5% of all users on Facebook are randomly assigned to this holdout group. And if you are in this group, then you never see any ads. So, you could go today. So this is a continuously running experiment. So you could go today and create 200 accounts on Facebook, and one of them would end up in this group, and that account will never see any ads for their entire history. And also the users, of course, in this group don't really know that, they are in a control group or the treatment group. So this is happening in the field. So we basically exploit this already running experiment to, look at the effect of, the utility of seeing ads or no ads. So what do we do in our study? So the experiment is running since 2013. We collected our data in 2022. So the experiment is, still ongoing, but the title says a 9-year experiment because that's when we collected our data. So what we do is we recruit a representative sample of Facebook users for the control group and the treatment group, around 40,000 users in the treatment group where they see the usual amount of ads, and around 13,000 users in the control group, the holdout group where they don't see any ads. So because it's Facebook, right? There are pretty rich weights which tell us how representative a given user is of the Facebook user base, and we have weights which tell us how representative they are for the control group population and for the treatment group population. And when we look at the balance across both the treatment and the control group, both the samples are very well balanced across a bunch of demographics and a lot of pre-treatment covariates. And when we also look at tenure on the platform, like how long you have been on Facebook, there is no significant difference between people in the ads group and the no ads group. Like the difference is like basically close to 0, which indicates that like attrition in the ads group is not of a particular concern in our setting. So once we recruit users from the control group of no ads and treatment group of ads, what we do is we measure their valuation of Facebook using an incentivized online choice experiment, and I'll talk about what exactly that is in a second. So we measure people's valuations of Facebook if you're in the control group or the treatment group. And if we look at the difference in valuations across both of these groups, that difference should basically reflect the utility or disutility from ads. Because the only difference for both of these populations is if you see the ads or don't see the ads. So users were invited to take part in our online experiment, which is basically a survey using an invitation at the top of the news feed. And the entire study happens when we elicit their valuations. All of that happens on the Facebook app itself. And the key evaluation question is basically measuring willingness to accept to give up Facebook. And the question which we ask is, would you keep access to Facebook or give it up in exchange for a certain dollar amount for 1 month? And that dollar amount is randomly varied across different users in our study. So we have prices, changing from $5 to around $100. Any given user only gets one of these choices, would you keep access to Facebook or give it up for $5, or someone may get $100, someone may get $50, and so on. And when we aggregate data from all of these users, we can estimate demand curves. So even though there are no prices and quantities readily available for measuring demand of Facebook, we can kind of construct them by using these choice experiments. A key design of our experiment is the responses are incentive compatible. So it's not a cheap talk response where you can just say oh yeah, I'll give up Facebook for $10. But users can be randomly selected. So there's a 2% chance of randomly getting selected to actually give up Facebook. And once we verify that they have given it up for 1 month, they get the cash at the end of the time period. And this is closer to more closer to a revealed preference approach than a stated preference approach. So we actually give out in total over $20,000 of rewards to different users who are randomly selected. So there is real money on the table. So it's in your best interest to respond truthfully. So around 400 are randomly selected. In total, we pay out over $20,000. One interesting thing, which we also wanted to look at is there is this concern that, if what we are measuring is actually a measure of, their consumer surplus or not, or is there some irrational behavior happening when we solicit these valuations? So, perhaps one could argue that, if there is digital addiction, users may not be, willing to come back once, they have given up Facebook for a certain period of time. So to look at those concerns, we look at how many users actually come back, after the experiment is over, and even 2 years later. And those who give up Facebook for the month versus those whom we didn't ask to give it up, the likelihood of being a Facebook active user is basically the same across both groups. So there isn't any difference across those groups, which means that whatever valuation we are measuring is measuring their valuation of Facebook. So this is how the key choice experiment looks like. So this is, again, an example for $40. Would you keep access to Facebook or give it up in exchange for 1 month for $40? Take it or leave it question, and you may be randomly selected and actually, given the choice. So let's look at some results now. So I'm now going to show you the demand curve of Facebook, across both samples, across the entire sample. So both treatment and control group pooled together. So this is how the demand curve looks like. So on the x-axis, it's the dollar amount which we offer people. On the y-axis is the share of the population which chooses to reject that cash amount and continues to use Facebook. So as you can see, it's a really nice downward sloping demand curve, and this just appeared, in the data. So any given user, appears only once in this demand curve. So when you aggregate it, it ends up as a really nice looking, downward sloping demand curve. So, around 19% have, valuation of less than $5. On the other extreme, around 24% have a valuation of over $100 to give up Facebook for a month. And this is data from all the 13 countries in our sample. So this is data pooled together. So when we look at, the median valuations, the median valuation across all the 13 countries pooled together is around $31, to give up Facebook for a month. There's a lot of heterogeneity across different countries, so around $11 in Romania to around $57 in Norway. US is around $48 to $49 for a month of Facebook. So now let's look at differences between control and treatment group in terms of valuations, and also we have some other data on time spent. So when we look at time spent, how much time people are spending on Facebook, what we find is users in the ads group spend around 9.4% less time. So they are spending less time if they're exposed to ads. One reason could be, that they may be clicking on the ad and leaving the platform and making a purchase or checking out some other website and so on. So that's one reason. We don't look into what exactly is happening with that, reduced time spent. But they do seem to spend less time. But when we look at valuations of Facebook, we don't find any significant difference in valuations between the control group and the treatment group. So users in the control group and the treatment group, in both of these groups, they basically have a valuation of around $31 for a month of Facebook. The difference is around $1, like $1 of disutility, but that is not significantly different from 0. If we do a simple calculation of what is the minimum detectable difference, which we could have detected with our sample size, so that's around $3.2 of disutility. So the total valuation of Facebook is around $31, $32. Potentially $3.1 to $3.2 is the minimum detectable difference. So if there were some utility or disutility, that's in the range of around 10% of Facebook's valuation. But we don't find any significant difference in our data. So this is how the demand curves look like for the ads group and the no ads group. So on the left, it's the unweighted data without applying any weights. On the right, it's the weighted data. Both of those demand curves basically look very similar. And what we find is that the demand curve for the ads group and the no ads group are basically overlapping with each other, across the distribution. So it's not just they're not just not significantly different at the median level, but also throughout the distribution, the valuations seem to be very similar to each other. We look at heterogeneity along a number of dimensions. So if we split the data by looking at heterogeneity based on time spent on Facebook, and split users into 3 terciles, based on time spent, low, medium, and high. Across all of these 3 groups, again, the valuations of the ads group and the no ads group, again, are very similar to each other. There is no significant difference. If we look at the data based on tenure on Facebook, like how long you have been on Facebook. So some users in our sample recently joined, while some have been on Facebook for over a decade. And when we look at data based on tenure on Facebook, again, no significant difference across the 3 groups, based on bottom tercile, medium tercile, and upper tercile of tenure on Facebook. If you look at heterogeneity based on region, again, no significant difference. If we split data, US versus Europe, and then we also have Mexico in our sample. No significant difference in valuations between the ads group and the no ads group, across all of these regions. If we just look at the point estimates, although they are not significantly different from 0. So if we just look at the point estimates, around $4 of disutility in the US. Around 60 to 70 cents of disutility in Europe, and around 15 cents of utility in Mexico. That's what the point estimates indicate, but again, not significantly different from 0. So, of course, in this work, we are just looking at Facebook. If we were to run a similar experiment on other platforms, like especially, if you take YouTube, the estimates would be quite different. YouTube, I think perhaps the distributed from ads is higher. We also only have extreme conditions like ads or no ads. We do not vary the amount of ads, the ad load. We do not vary the amount of targeting which goes into the ads. So that is something one could explore perhaps in future work. So to conclude, there's a lot of policy debate, right, on measuring, or a lot of policy debate around, are ads good or bad, and lots of regulations which are being proposed around it. But there isn't a lot of work putting a dollar amount on the distributability of ads. And here, we provide one of these estimates for Facebook in the long term. But it's important to know that, we are only looking at part of the equation. So we're only looking at, consumer surplus from ads on the Facebook app itself, like either by seeing the ads or not seeing the ads. If you wanted to do a full welfare calculation, you should also look at, if you click on an ad and make a purchase, what is the consumer surplus you get from that? There's also welfare, going to advertisers, welfare going to the platform, and so on. And I know my co-author, Nils, has other work looking at the advertiser side. So here we are just looking at the consumer side and just on the platform by seeing ads or no ads. And of course, in future work, I would love to explore more about, what exactly is happening. So the differences are not significant, but there could be some benefits, there could be some costs, and is it because of the benefits canceling out the costs or not? Yeah, so that's it, and I look forward to your questions. Thank you.
I'll just ask one question. I mean, it seems like one of the big, amazing things here is there's this long-running, great experiment.
Yeah.
But then you sort of have the smaller selected sample. And so how do you think about kind of you argued that there are these great weights that we have.
Yes.
But I might be worried that some people have quit using Facebook because of the ads or weren't around to answer the survey. And and that would sort of tilt things towards people who value Facebook more still being around in the ads condition.
Yeah, so that was definitely a concern. And we look at a few pieces of evidence. So first is because the experiment is continuously running. So we have users who recently joined, users who have been there for a while. So we have users of different tenures, and that's what we look at in one of our analysis. And then the second point is if you look at their average, their tenure on Facebook, both of those groups are basically the same. So the difference in tenure for control group and the treatment group is basically the same. Of course, if someone already quit, they would never be in our sample. But at least it's encouraging to see that in both of these groups, the tenure is very similar.
Well, thanks. I think we'll have a lot more to discuss about this.
Thank you.
Okay, so it's my pleasure to introduce our next plenary speaker, Jessica Hullman from Northwestern. Take it away, Jessica.
Sure. All right, thanks. So I'm going to talk about benchmarking information displays for data-driven decisions. And specifically, I'll mostly talk about a paper called the Rational Agent Benchmark for Data Visualization. This is joint work with Yifan Wu, Xiang Guo, Michaelis Mamakos, and Jason Hartline, all from Northwestern. So I think most of us here probably care about this question: what can we learn from data to inform or drive some decision process? Whether that's an exploratory data analysis when we're trying to figure out signal from noise and decide do we need to collect more data, randomized experiments where we're trying to figure out things like when to stop an experiment, and prediction where we might care about the predictability of some phenomena. But what can be learned from a given data set is not a function only of the information content in that data, but it's also a function of how we display the data. So we know from a lot of studies on visualization and other formats for displaying data that these choices of how we aggregate, how we encode probability, using different visual variables, all matter very much. And so as a case in point, it took upwards of 30 years to discover some very important errors in this famous antibiotics data set, in part because the way it was initially displayed was not easy to read. And so, we might think about, well, these display effects matter, but how do we study these effects themselves so that we can make sure we're using the right display for whatever decision problem we're trying to support? And so, if we look at sort of the status quo, for studying display effects, this sort of gold standard might be a randomized controlled experiment where we're going to ask a question like, how do these different visualization displays for some decision task rank? And then we're going to basically run a study. And so here I have maybe 3 different ways of visualizing a temperature forecast that I might care about. So I have a mean with a 95% confidence interval, I have a gradient plot, and I have this hypothetical outcome plot, which animates on the left. I think my animation stopped. But when I set up a study, any experiment like this, I have a lot of decisions I have to make. So first, I have to find a way to generate data and visualizations, which we might think of as a data generating model. So let's say that my temperature forecasts are all going to be normally distributed, and maybe across the different stimuli in my study, I'm going to fix the mean at 5 degrees Celsius, but I'll vary the standard deviation, and maybe I'll choose uniformly from some set. So now I have a bunch of temperature forecast distributions. This is actually the daily low expected temperature that we're forecasting here. And that's because we want people to do a decision task that's going to involve whether it's going to freeze or not. So that's sort of the payoff relevant state that we're going to ask them to think about. And there's a nice mapping between the fine-grained state of temperature and this coarser payoff relevant state theta. The decision, and before I get to the decision task, I'm also going to visualize the data in different ways, because this is a study about understanding the effects of these visualization strategies. So I have these 3 different visualization strategies. I'm going to apply each of them to all of my temperature forecasts, perhaps, and that gives me this set, capital V, of visualizations. These are the stimuli in my study. All right, so in terms of the decision task I want to elicit responses to, I'm going to ask people to look at these temperature forecasts in my study and then tell me whether they want to salt the roads or not, based on whether they think it's going to freeze or what they think this probability is. And whenever I set up any experiment, I have to have a way of scoring decision quality if it's a decision experiment. And so here, I could use something like accuracy, which is going to balance errors or treat them the same. Or I could use something that's going to weight errors differently. So here I might think that their false negatives are actually the worst kind of error. So people, if they don't salt and it freezes, people might get in accidents. So, so these participants are pretending that they have to make this choice. And so I run my study. And here's what my results might look like. So I have my performance metric on the y-axis here. This is the average score of participants in each of these conditions after I run this randomized study. And what I see is that, oh, look, the gradient plot appears to be performing the best. People in this condition made the best judgments or decisions. And so, what do I conclude? Well, the typical study that I see on things like visualizations would maybe conclude that gradients are better here. Maybe I ran statistical significance testing, and I've convinced myself, this is a significant difference. And so then I might go on and generalize from my study, this very specific task, and say something like, well, we should be using gradient plots to support weather decisions. And so there's, a question here about how much this generalization and simply this conclusion that gradients must be better is really warranted on this data. Like, should weather forecasters all over the country really be scrambling to update their visualizations? And the problem, with just stopping here and just concluding, we found an important effect is that the study results that I just presented, like many sets of study results we might use in these randomized controlled experiments, are ambiguous. It's a little bit hard to tell what exactly we've learned. So for instance, you can see that gradients are better. They got a higher expected performance in my study. But how much better are they? And does this difference actually matter in any way? How do I understand how important this difference is? One of the things that would be nice is if I could actually understand sort of what performance is attainable in the decision problem that I've induced when I designed my study. So if I knew, for instance, that the maximum achievable score of any participant was over 1,000, and maybe the score I would expect if someone used a dumb strategy, perhaps that didn't even use these visualizations, is around 20, well then there's this huge range of possible performance, and we see that all of these visualizations are down near the bottom, and so all the options look bad, right? And the point is we don't really care about the difference between them if this is sort of the range of performance we might expect. On the other hand, maybe all of the visualizations are close to this upper bound. And then again, we don't really care about the specific differences between them, perhaps, because all of the options are attaining, close to the upper bound, over 90% of the way there. I think the default that we often assume is that we're in a situation something like this one, where this difference between the visualizations is a pretty large chunk of this range between sort of a dumb lower bound strategy and the maximum attainable performance in the study. But the point is we often don't know. We actually don't go through sort of the process of trying to understand what's possible given this decision problem we've induced. And so what I want to talk about today is an approach that we've developed that can be applied just using statistical decision theory to sort of better understand what we're learning from studies like this. And in particular, what we want to know is something about the value of the information in these stimuli to the decision problem that we're studying. So if we want to understand, how much can these displays possibly help, like I said, we might want some upper bound representing best attainable performance when you rely on these visualizations. And we might want to compare that or know how far that is away from a dumb strategy where someone is not even necessarily using the visualization. And we can call this span here the value of information to the task. And we care about how big this is because it tells us something even before we run the study about how much room there is to see an actual benefit from looking at these visualizations or these displays in our study. But it's also very useful as a normalizing unit. So again, we're going to run the study at some point. We're going to get human participants to do these tasks. And we can use this as sort of a normalizing unit to understand how far of the way there are human participants getting in terms of their own use. Okay, and so what we're going to do here to compute these bounds is rely on this idea of a rational agent who's going to, we're going to simulate this rational agent doing our experiment using these visualizations, and we're going to compare their expected performance to that of our behavioral participants, our humans. And so by rational here, I mean a Bayesian agent who's going to start with some information about the experiment design, the prior. They're going to see the visualizations on any given decision trial. They're going to update to form posterior beliefs, and then they're going to choose the utility maximizing action. And like I said, we'll compare that to the expected score of participants after we run our study and we model the results. And so to give you a little bit more insight into what this looks like exactly to use this rational agent, let's go back to this decision problem study that I already showed. And remember that we had a way of generating our stimuli, which we could say is the data generating model for this. And what's important here is that when we generate data and apply these visualizations, what we're actually sort of creating is a joint distribution over the signals, these visualizations, and the state, which again, in my example here, the state, the payoff relevant state that your decision quality depends on is whether it's freezing or not. So we have this joint distribution over V and theta. And we can imagine a rational agent comes to the experiment, and the task of any participant is really to be trying to learn about this joint distribution, right? So the rational agent comes to our study. We assume that they know the prior. So they basically know the prior probability it's going to freeze, which is defined over this joint distribution, which is defined by the way that we've created the stimuli. If we care about the rational agent, of a dumb strategy, a strategy where the agent is not actually relying on the visualizations, what we can do is imagine this rational agent, and they have this prior, but now we're not going to show them the interface on any given decision instance. So they have to basically figure out what is the best fixed action that they could take over this set of decision instances without access to the actual displays. So they choose, they have the prior and they choose the utility maximizing decision under the scoring rule that I showed you earlier. If we want to understand sort of maximum attainable performance, we're again going to use this rational agent. But now we're going to assume, they start with the prior, but then on any given decision trial, they can see the visualizations. And the visualizations inform about this payoff relevant state. So, the rational agent's going to look at a visualization and get information about the distribution over states. And this is sort of an optimal agent. And so in contrast to human participants, we're going to assume that the rational agent understands how to read the different visualizations. So, a human might struggle to understand or properly interpret a 95% confidence interval, but a rational agent knows that if you show me a 95% confidence interval, I can use that interval to get at the standard error, and from there I can get to the standard deviation if I know the sample size. And so, they can imagine what this underlying normal distribution looks like, and they can figure out, what's the probability it's going to freeze and respond. So this allows the rational agent to arrive at posterior beliefs, and finally to take, again, the utility maximizing action. Okay, so this gives us this upper bound, which is the expected score of a rational agent on a random trial from our study, given that they've learned optimally from the stimuli and taken the utility maximizing action. All right, so how do we use this framework? Well, it's useful at a couple different points in this process of running a study. So first, before we even run our study, let's say we've designed some stimuli, we think we have something that might be interesting. What we want to ask is, well, these displays, whether it's visualizations or some other presentation format, what's the value of the information that they're actually going to give the participants? And so, if we have a score, some performance scale that we've set up, what we would hope to see is something that doesn't look like this. So here we have our upper bound and our lower bound, this rational agent with access to the visualization and without, and they're very close together relative to sort of the natural lower bound, which is 0 on this score. And so, this value of information unit, which is here in terms of the units of the scoring rule, is pretty small relative to this, span we see on the chart. And so, we could say this study is kind of dead in the water, which means, if we're actually trying to study important differences between visualizations, here we can't even really distinguish well between not even looking at the visualization and best possible use. So, there's not much room to see anything interesting. What we want to see is something closer to what's on the right here, where there's a pretty big span between these things relative to sort of the natural lower bound on this scale, because then there's actually room perhaps to see something interesting. Okay, and so another way that we can use this before we've even run our experiment is whenever we have different displays or visualizations, for instance, that have different amounts of payoff relevant information that they offer. So, for instance, maybe in my study, I also had just the mean of the forecast. That's all I showed people as one display. This is a study of decision-making under uncertainty, and so if you're not getting any information about, variance, then that's going to do worse. And so, we can really think about whenever we have multiple displays that offer different information, multiple benchmarks. So the rational agent's performance with the best display versus these other displays. And so then we can look at the difference between the best possible performance with any display in the study and each individual display. And this allows us, a priori to calculate sort of, what is the loss we expect simply because we're giving people a less informative interface. And so then when we run our study and we get our results, we can then understand or not have the confound of trying to compare people across conditions that actually offer different amounts of relevant information. All right, so post-experimentally, now let's imagine we've actually run our study. And we want to use this framework now to understand what we can actually learn and to begin to separate out sources of loss. So I've reoriented my scale here. Now I have the benchmark on the right and the baseline on the left. And I'm going to imagine I'm looking at the results from just a single visualization strategy, say maybe the confidence interval, just for simplicity. So I run my study. I have behavioral agents, humans, do my task. And then what I want is to know the expected score of a random participant, which is typically something I get when I model my data. And I could just use the empirical distribution if I wanted to, depending on how complicated my design is. So you notice, there's this big space, between the maximum attainable performance, the benchmark, and these human performance. It looks like the humans are attaining maybe slightly less than 1/3 of the possible sort of gain from having access to that visualization. But I might wonder why this is. And typically when I run my experiment, even if I calculate a benchmark, it's I still have to try to figure out like what's the reason people are losing performance. And so we can think about maybe different sources of loss. If we think about how an agent goes about learning from these stimuli. There's one problem in a human agent relative to a rational agent, which is simply that the human agent might not extract all of the decision-relevant information from the stimuli. So we could call this extraction loss. I can't read the visualization to get all the information. On the other hand, we can also separate out optimization loss, which is basically conditional on whatever beliefs I arrive at from the signal. I might not be able to choose the optimal action under the scoring rule. And so the way that we're going to sort of disambiguate these is, again, using this notion of a rational agent. But now we're going to use the rational agent to calibrate the human behavioral participant scores. And so you can think of this as sort of previously to get the benchmark, I'm giving the rational agent information about this joint distribution between the signals and the states, the visualizations and the states. But now to get this calibrated behavioral agent score, I'm going to take my rational agent and I'm going to give them information about the joint distribution between the human decisions and the states. So they no longer are going to look at the signals. They're only going to be able to sort of extract the information in the human signals. And so this basically is a way of sort of fixing these optimization errors that actual humans might make. And so this difference between the calibrated behavioral agent and the behavioral agent is one way of estimating sort of, what are the losses simply from not being able to figure out the right action. The remainder over here, the difference between the rational agent benchmark and the calibrated behavioral agent, gives me an estimate of this extraction loss. So how much, with this particular display, were people struggling to actually get the information out? And so here I'm just showing, results from a single visualization strategy. But what I actually want to do, when I have my study results, is compare these different sort of error sources and the proportion of loss across these different conditions from these different sources. And it gives me a sense of sort of how exactly are different visualizations resulting in different sort of issues. All right, and so you might sort of be thinking as I talk, well, really what are the differences between the rational agent doing this study and the human participant? Like, is this a fair comparison? And one of the implications, I think, of analyzing experiments this way is that it tells us something about what we should be doing in terms of communicating our design to participants. So whenever we design some study like this to study decision making from any kind of information display, the way we design our experiment induces some decision problem that we could model or represent using statistical decision theory. A problem, though, is that often maybe we don't think about it in this way, and so we might communicate only part of that decision problem to the participants in our study. So for instance, I might analyze the results using some scoring rule, but not actually give that scoring rule to my participants. Or I might have a visualization display where participants do need to know the prior in order to extract the relevant info and arrive at the right posterior beliefs, but I don't give them the prior. The problem with this is that once I get my results from my study, if I've sort of underspecified the decision problem for the participants, I should be expecting differences between different people simply because they are taking different guesses about what the decision problem actually is. So people are going to sort of fill in the gaps in different ways, and then I'm going to get my results. And the problem is that I don't really care about differences because people brought different priors. What I really want to know is the differences between actual benefits of these displays, and so it's confounded. And so like one of the takeaways or implications of this is that if we want to have an interpretable evaluation study of decision making, we really need to be communicating all of the necessary components of our decision problem for a rational agent to optimize, which means the prior, if the prior matters. Sometimes the signal itself, I should say, actually will communicate the posterior belief. So sometimes you don't need to give the prior. But if you need the prior, we should be communicating the prior. We should be communicating the scoring rule, et cetera. And so we have another paper where we get into, the sort of comprehensive set of losses that you can conceive of, within this framework. I've only talked about a few here. All right, there's also many ways to extend this framework. I should do a quick time check. Does anyone know? 5 minutes left. Okay, great, thanks. So yeah, there's also interesting ways to extend this. This is one of my last slides. But we've been using this notion of decision-theoretic framework with a rational agent to look at problems that a lot of people are thinking about right now related to sort of optimal use of prediction displays. So in many cases, we have organizations who want to deploy an AI to assist with some decision process. They might not be ready to get rid of the human, and so we have these questions about, for instance, how do we measure appropriate reliance on an AI or a predictive model? And so one way that we can use this framework is to define sort of the best attainable performance of a human and an AI team. And so here what we're going to do is assume that we have a rational agent, and the way we're going to frame the decision problem to that agent is that they are trying to make the optimal choice between a human signal or a human recommendation and an AI recommendation. So we assume, for instance, we have some doctor. The doctor has their own judgment about the right diagnosis for some image. We have an AI model that's making a prediction, and then we want to figure out what's the rational agent's expected score if they do the optimal thing, choosing between those. We can then, again, look at where the human with the AI falls. And here we can decompose other sources of loss, like the loss because you're not relying on the AI the right amount of time versus the loss because you're not relying on the AI at the right times, like at the right decision instances. Another thing that we can do, also relevant when we're trying to pair statistical models in humans, is use this framework to try to identify when some feature that we think is available for the decision problem could be used to improve human decisions. And so here we can look at, for instance, if we give a rational agent human decisions on some task, say a diagnosis task, how much does the rational agent's expected score on this decision problem improve when we also give them access to one particular feature or set of features at a time? So we can sort of see when is there potential to try to improve human decisions by focusing the human's attention on other information. And finally, this sort of way of thinking about decision problems and in particular information displays has helped me understand better as someone who studies sort of uncertainty quantification and uncertainty communication, exactly when we can say something about the optimal use of some display and when it's harder. So for instance, there's a lot of work right now in predictive uncertainty. How do we display uncertainty in classification results? And some of these approaches, they're distribution free, which is nice. We can apply them to some arbitrary classification model. But it's interesting and I think insightful to figure out, by looking from this rational agent perspective, what exactly we can or cannot say about how someone should use that, way of quantifying uncertainty. So anyway, lots of possibilities. So I'll just summarize here. We really cannot understand the impact of these display choices without also, considering the usefulness of the information they provide to the decision problem. We can rely on statistical decision theory within a framework like the one I've shown to help us bound attainable performance and use this both pre-experimentally to improve our experiment design or vet our experiment design and post-experimentally to understand what went wrong with the human participants who were in this task or who made the actual decisions. And I should say as well that while I had sort of a decision task with a small action space, you were only choosing between two actions. This might feel like a classic decision task. This kind of approach is actually very broadly applicable. We can apply it to tasks where we want to elicit people's beliefs, like a probabilistic belief. The only thing we really need is that you should have some decision problem for which you are willing to say it is possible to define ground truth, and you should have some variance in the state. So if I had a study that only had a single visualization that everyone saw, then it would be challenging. Otherwise, it's applicable. So I will stop there. Thank you. I'm happy to take questions if there's time.
Great, thank you. We'll now have Avi rejoin us, and we'll have some more conversation about this. Just to start things off, I think a natural thing to think about with these two talks together is how some of what you talked about might apply in the context of eliciting preferences, rather than sort of a decision task or something where you're eliciting beliefs. And I wonder if that's something you thought about as well.
Yes.
Yeah, like sort of the exact kind of thing that Avi was just sharing.
Got it. Yeah. I mean, you can certainly use this to try to learn about like decision thresholds people have, which sort of one way of understanding preferences, I guess. So if I have a bunch of different participants and I think that their decision criterion is different, then the sort of approach I'm taking will show you that through this optimization error. I'd have to think more in terms of, if you want to do something more open-ended with preferences. What I'm talking about is mostly meant to sort of help us create these comparison points. So yeah, I'd have to think about it more.
I guess just in the context, say, of eliciting people's willingness to accept these offers, we might wonder, if somebody somehow completely misunderstands this problem and is not, is making choices at random, how much worse off do they end up? Or if somebody really fully understands this, incentive compatible scheme, how well are they doing? Because there's actually a lot of challenges in computing sometimes these, or communicating these schemes to people when doing these willingness to accept experiments. And I wonder how you thought about, the choice to do this in this people choosing a single gamble versus having them do a, sealed second price auction BDM type mechanism.
Yeah, so in my other work, I have compared all of these methods, like take it or leave it, just single one choice versus a BDM mechanism or a multiple price list. And from my experience, if you explain the process well and have comprehension check questions, and make sure they can only proceed once they once they get the mechanism properly, then all of these three methods basically we're estimating the same valuations. So at least in one of my other papers, that's what we found. So BDM, take it or leave it, or a multiple price list, all of them were leading to the same, basically the same valuations. Yeah.
I would just also say, I think there's a lot of work to do in terms of these kind of behavioral experiments we run with different types of information we're showing people, just on figuring out how to sort of best estimate these losses, not just the sort of estimation test, but what do we elicit from humans? So if the prior matters to some problem, we probably want to elicit back whatever the prior is after we've conveyed it and figure out exactly how much error is there. One other point I wanted to make now might have escaped me.
And just to clarify, that was kind of critical to this ability to have this rational agent calibrated version, is that you also need some elicitation of the participants' beliefs.
No, we're not doing that. No, okay. I think what my point at the end was just that whenever we're trying to evaluate people's decision making, there is some decision problem that we have induced, involves how we evaluate the results, what the stimuli were, et cetera. And my point was that we have to communicate all of the relevant components if we're going to evaluate people according to some decision problem. We can't only communicate part of the decision problem and then think that we're, actually able to separate things. Oh, my other point was related to that, which is that, I think whenever we're trying to hypothesize about how people made decisions, it's sort of like we're always testing this joint hypothesis, both that they understood the decision problem and whatever the hypothesis is we care about. And so it's sort of, I think it's hard to escape, some uncertainty about whether, did the participants fully understand this problem the way we meant it? But you can certainly, I think we could do a lot more, and this is what I mean by there's work to do in sort of understanding how to best kind of minimize these losses in terms of figuring out what can we elicit that gives us a very, a nice way of, really trying to pinpoint these different sources of error.
Cool. I think we have a few microphones circulating if there's questions from the audience. Okay, yeah, there's one here and one here.
Hi, two fantastic talks. Thank you. This is a question for Avi. It's actually a suggestion and a question. So the suggestion would be, if you do it again, get a bin that has annoying ads and innocuous ads. So in our paper, we found that animated ads drove people away from the site, but static ads had no effect on people leaving the site. And as Dean said, once people have opted out of returning to the site, then it becomes difficult to measure things in the future. But then the question is also about how many people actually saw the ads. Because of ad blockers, the treatment group might be much smaller than you think, and then the standard errors would be off.
So great suggestion regarding, let's say, potentially also varying the annoyance of ads like you do in your experiment. I think that would be hard to do it in the field, but yeah, definitely.
For 9 years.
Yeah.
There's a tag for animated versus.
Right. Regarding ad blocker, I'm not too worried because most of the people are using it on their mobile phones, and it's just impossible to block ads on the Facebook app on your mobile phone. So majority of the usage is coming from there, but yeah, I think it would be interesting to look at split between desktop versus mobile and on desktop ad block versus no ad block.
Well, I think we had another question right here.
Hello, thank you very much for your very insightful speeches. And I wanted to ask actually two questions. Maybe I will start from one to Professor Hullman. I wanted to ask if experimental methodology can be relevant also for instance, disinformation recognition. Because I understand that there are some differences, but maybe you've seen some research papers on that?
Yeah, I think there's lots of people trying to sort of understand how well people can detect different types of misinformation. I think in terms of modeling it as a decision task that could be solved, I'm not sure. I guess I think you could. Yeah, you have labels basically, I guess, of as long as you know what is actually true and fake.
Yeah,
then, I think you actually
that's
could
the
do that.
problem.
I think you have to create probably your own. We're running a lot of studies right now actually on how well people can detect deep fake images, and so
exactly.
You sort of have to create your own. You can't be finding them because then there's this uncertainty about the true state. But otherwise, I think that'd be great.
And just to follow up on that, at least a lot of the framework you're working in would really recommend thinking about some concrete decision problem. And so that could, what that problem is could really depend on, what the role of the subject in such an experiment is playing. Are they a moderator? Are they a platform? Are they just another user who's deciding whether to, reshare something or not? And of course, then the relevant kind of scoring rule and losses would be very, very different across those situations.
I think there's also ways to sort of evaluate over multiple scoring rules at once. This is an area of work in theoretical computer science right now, and so you can also do something similar to what I was doing, but take more of a robust analysis approach, where you're saying what would be the optimal thing to do if there was ambiguity about what the true data generating model was, or or about the scoring rule. So
Thank you. Is this study on deepfakes already published, or?
No, but this is with my colleague Matt Groh. So we have, I forget the URL, but we have an experiment that's running and collecting lots and lots of this, and we're in the process of submitting. So hopefully some interesting results on just how good people are at recognizing deepfakes.
Okay, super. Thank you. Very interesting. And maybe one more last question, because I wanted to ask you about Professor Collis. I wanted to ask you about, did you take into account people's prior usage of Facebook? For instance, how much time they spent before? Or, I don't know, countries? I've seen countries, but maybe more, let's say, countries with lower income, even lower than Romania. Would be important to check. Thank you.
So we have 13 countries, and I think, Mexico, we don't have very low income countries, but I think we have Mexico and Romania. In another paper I have, we look at valuations of Facebook and how that correlates with income levels. And what we find is lower income countries and lower income people value Facebook, but also other digital goods much more relative to their income compared to the other groups. So that's what we find, but yeah, we don't have very low income countries in the sample. Yeah, yeah.
Well, and I think so. I mean, that you do look at how these results vary by their tenure and their time spent.
Yes. Right.
The time spent, but just the frequency, how often people
How often? Yeah, right. Yeah. So far, we just look at time spent. Yeah.
Cool. Yeah, maybe we have another one right here. Is that?
It's a bit too loud. This is a question for Professor Collis. I do see your point that if you're given sufficient information before the study about what the survey are supposed to do and ask them to specifically consider the information, then you would, I guess, get a pretty good estimate. But I feel even then, at the end of the day, Facebook is something that you do not necessarily have a price tag on. And so I would be curious about the effect of a second round, because say if on the spot I think that I would be pretty willing to give up Facebook, but then a moment later, like say after 10 days, I realize like, oh, this is the only major media platform that I can use to connect with my friend, then I guess like my price tags would change significantly by then. So I would be curious on a second round specifically for those in the, I guess those that said yes.
Yeah. Great point. We haven't done the second round, but yeah, it would be interesting to see. What we do find is, when we reach out to people who are selected, offer them cash, not everyone takes up on it. Like, so I think around 60 to 70% follow up and actually take the cash. But the others, once the real money is on the table, and then they also realize the consequences, maybe some of them don't do that, which also means that the valuations here are underestimates. Like, if you wanted to measure the true value, then probably those who are backing out, value Facebook more. But also the valuations, the mechanism is similar across both groups. So when we look at differences, I'm not too concerned about the difference. But you're right. If you wanted to have an even better estimate, we would look at what happens, once you live without it for a while, and
And I think just some of the broader context is that there's some other willingness to accept and social media deprivation experiments that have done kind of a second round. But usually, at least my sense of the headline results is that they're the opposite of what you suggested, which is that people's valuations drop after a period of deprivation, which sometimes has been interpreted as evidence of addiction. But I think there's a lot of assumptions that would go into that. I don't know what your take is of that on that work.
So in our data, we look at those who give it up versus those people we reach out to versus the people we don't reach out to. And when we look at how active they are on Facebook, like a few years down the line, what we find is it's very similar. Those who gave up came back at similar, and then the activity on Facebook was similar for both of those groups. That's what we see in our data. But you're right. I think the other papers like Alcott, Jenskow, and all, they find valuations go down a month later.
Cool. Oh, yeah.
Hi, thank you for the great talks. I have a question for Avi. I was wondering if you have looked at the another heterogeneity question, at the difference that whether a person likes ads. So I think by default, we're assuming that people hate ads, and now the average treatment effect is that no, ads don't drive people away from the platform, but maybe some people like it, and actually we have two groups of people, so maybe, and I don't know if your data allows you to look at that. So to me personally, ads, relevant ads on Instagram is something that makes me like Instagram more. And maybe there are two groups of people that have, like, the people who like ads have a positive effect, but there are other people who are, have a very low willingness to give up Facebook. I was wondering if you are looking at that kind of heterogeneity.
Yeah, that's a great point. So right now we haven't looked at it. I think definitely something I can ask my Meta co-authors if that is properly tracked, who is looking at the ad and not. One thing I did look at in another paper with Meta is how does Facebook valuation correlates with ad revenue, which is probably correlated with, if they're looking and clicking on the ad. And we find a positive but not perfect correlation. So people, the groups where Facebook makes more ad revenue, they also value Facebook more. But that correlation is not perfect, but there is a positive correlation there. But yeah, it would be interesting to see how our treatment effects change based on those who like perhaps and look at it more versus don't.
Yeah, and I guess I would sort of imagine that that a lot of this association can just be driven by some people have valuable eyeballs, and they also are richer and have higher willingness to pay for things, right? Is that how much should I think that those kinds of associations are driven just by that?
Yeah, that could be very well true. We haven't looked at that, but we haven't controlled for income and other things when we looked at this analysis. But that is something we should look at. Yeah.
Okay, I think we have a question over here as well.
A couple questions to Avi. The first one, when you're thinking about the holdout with no ads, did you compare bot profiles between ads and no ads? I could imagine some bots want to scrape ads on Facebook, so you might have a different distribution for bot ads between the two. And does that actually impact how much they value Facebook, so kind of fraud traffic or bot traffic in general? And the second question is about kind of more ad effect leakage. So the holdout group doesn't know they don't see ads. Is it possible that they still perceive they see ads? Because we know Facebook has a lot of ads. So is there a way to separate in a survey as well, what's their perception of ads, if that's kind of what we're trying to be different between treatment and control? Because they get exposed to Instagram, so they see ads from Facebook on Instagram. They're exposed to the news about privacy and all of that. So even I think the user perception could play a role in how much they're valuing the Facebook experience. But I don't know if that, if possible, of a survey to ask about the perception of a user for ads.
Yeah. So on the first question, so the sample we're looking at, these are real people who took part in our study. So they definitely are not bots. You're of course right. In the overall overall population, there are probably some bots. I don't think it's a significant percentage, but at least in our sample, these are all real people. And the second question, it would be interesting to see. So there is a lot of other research looking at perceptions and more stated preferences, around do you value ads or not? And I mean, my guess is stated preferences of do you like ads or not are probably very different to actually valuing ads in the field in dollars. So I mean, in my view, it's a feature that users don't know they are part of this control group or treatment group. But definitely, I think it would be interesting to explore this more. How do perceptions vary? How do they are they in line with valuations or not?
Cool. So we are actually out of time for this session. I need to go to our coffee break. But I think these are both really interesting talks. This may be the longest running experiment that's been featured in Code, and I'm also really excited that that Jessica's here to kind of help us connect more with the information visualization community, which I think is a natural one for us to think about. So thanks to both of our presenters.